NASA got a huge Christmas gift this morning when it successfully launched its most powerful space telescope ever.
So when we walk out under the stars and look above us, we're not seeing the stars as they are today.
For centuries, humanity has gazed at the stars, asking one of the most profound questions. Are we alone in the universe? Scientists, philosophers, and dreamers alike have wondered if other planets might harbor life forms perhaps as intelligent as us or even more advanced. In the last few decades, this question has transitioned from the realm of philosophy to the realm of science. With technological advancements, telescopes like the Hubble and now the James Webb have unlocked views of distant worlds unimaginable before. Among the many exoplanets studied, one stands out as particularly fascinating: Proxima B, a rocky planet in our neighboring star system, Proxima Centauri. Proxima B isn't just another exoplanet, it's tantalizingly close to Earth at just 4.24 light-years away. Could it harbor alien life? Could it hold the key to humanity's future in space? The James Webb Telescope's recent discoveries may finally offer clues to these monumental questions. The discovery of Proxima B. Proxima B was discovered in 2016 using a method known as radial velocity, which measures the gravitational wobble of a star caused by the orbit of a planet. This detection marked a significant milestone because Proxima B lies in the so-called habitable zone of its star, Proxima Centauri. The habitable zone is the distance from a star where conditions are just right for liquid water to exist. For Earth, liquid water is the cradle of life, making planets in such zones prime candidates for study. However, Proxima B's journey to stardom as a potentially habitable world has been anything but straightforward. Proxima Centauri, its host star, is a red dwarf, a type of star much cooler and smaller than our Sun. While this means Proxima B orbits very close to its star, the proximity comes at a cost. Red dwarfs are known for their intense solar flares, which could strip away planetary atmospheres and expose the surface to lethal radiation. Yet despite these challenges, Proxima B remains one of the best candidates for habitability in the universe. And now with the James Webb Telescope, we're seeing it in a whole new light. The James Webb Space Telescope, a game changer. The James Webb Telescope, launched in December 2021, is the most advanced space observatory ever created. With its infrared capabilities, it can peer through dense cosmic dust, analyze atmospheres of exoplanets, and provide unparalleled insights into distant worlds. When the James Webb focused its lens on Proxima B, scientists were astounded. For the first time, they detected signatures in its atmosphere that hinted at the presence of carbon dioxide, water vapor, and even methane molecules associated with life on Earth. What's more intriguing is the combination of these gases. On our planet, such a mix is often a result of biological activity. The telescope's findings raise tantalizing possibilities. Could there be forests releasing oxygen, bacteria producing methane, or oceans teeming with microorganisms? While we cannot confirm biological life yet, the evidence paints a picture of a world far more dynamic than previously imagined. Life on Proxima B. What could it look like? It's highly possible that the life that lives on Proxima B would be very different from anything that exists on Earth. How come? Due to the fact that the conditions on Proxima B are quite harsh. The planet is tidally locked, which means that one side of the planet is always facing its star, while the other side is always in continuous darkness. One side is burnt by perpetual sunlight, while the other side is frozen in endless night. This results in two habitats that are completely different from one another. It is possible that the terminator zone, which is the thin boundary between day and night, is the most promising place for life. Temperatures in this zone might be exactly suitable for liquid water. If life exists in this area, it would have adapted to the specific conditions that it is found in. When exposed to radiation, organisms may build thick, reflecting skins or exoskeletons in order to shield themselves from the negative effects of radiation. It is possible that life forms that are found in the dark regions could be similar to those found in the deep oceans on Earth and could thrive in geothermal pockets under the surface. Microbes are able to survive in some of the harshest settings on Earth, including volcanic vents and freezing tundras, making them the most likely candidate for life and the most likely candidate overall. With that being said, it is not possible to completely rule out the potential of more complicated forms of life. The role of water in Proxima B's potential habitability. The discovery of water vapor in the atmosphere of Proxima B is one of the most significant achievements in the investigation of this exoplanet. Water is an essential component of life as we know it, and water vapor was found in the atmosphere of Proxima B. Alternatively, liquid water might be found in underground reserves that are shielded from potentially hazardous radiation, or it could be found in limited stable zones on the surface. There is a significant positive correlation between the existence of water and the possibility of habitability. It is possible that it may perform the function of a solvent for biochemical reactions, just as it does on Earth. Imagine underground oceans that are alive with microbial life or ice surfaces that are hiding hints to ecosystems that are found in other worlds. Our study of extremophiles, which are organisms that live on Earth and thrive in harsh settings, provides the foundation for these hypothetical situations, even though they are theoretical. Proxima Centauri's double-edged sword. Both giving and taking are present in Proxima Centauri in equal proportion. Despite being much closer, Proxima B is able to orbit within its habitable zone because it is a red dwarf, which means that it produces a significantly lower amount of energy than our Sun. Red dwarfs, on the other hand, are extremely volatile, exhibiting flares that are both frequent and severe, which have the potential to wreak havoc on the atmosphere of a planet. The question of whether or not Proxima B possesses a magnetic field that is powerful enough to deflect solar storms is one of the most important problems that scientists are trying to answer. It is possible that life on our planet would not have been able to survive if it were not for the magnetic field of the Earth, which shields us from the damaging radiation of the Sun. The absence of such protection on Proxima B could result in an atmosphere that is either very thin or non-existent, hence lowering the likelihood of surface life. The future of exploration. Breakthrough Starshot. The distance between Proxima B and Earth is 4.24 light-years, which is both tantalizingly close and painfully far away. Using the technology that is available today, it would take tens of thousands of years to eventually reach it. Nonetheless, ambitious projects such as Breakthrough Starshot are working toward the goal of changing that. Using a considerable proportion of the speed of light, this endeavor proposes sending light-powered spacecraft that are extremely small to star systems that are located in close proximity to them. Because they are fitted with cameras and sensors, these microprobes have the potential to travel to Proxima B in a matter of decades. In the event that they are successful, they will be able to offer direct photographs and data regarding the surface of the planet, its atmosphere, and possible signs of life. The James Webb Telescope and other forthcoming missions will continue to collect vital information in the meanwhile. Observatories such as these will continue to gather data. Every piece of information puts us one step closer to determining whether or not Proxima B has the potential to become the next frontier for civilization. Why Proxima B matters for humanity. The investigation of Proxima B is not only about discovering life on other planets, it is also about gaining a knowledge of our own planet and its position in the universe. By investigating the factors that make a planet habitable, we are able to obtain a better understanding of how to safeguard the delicate ecosystems that exist on Earth. In addition, the discovery of life in other places would have significant repercussions for the fields of philosophy, religion, and the development of humanity's sense of identity. In addition, the search for life on Proxima B is a step toward the exploration of interstellar space. If it is possible to demonstrate that life exists beyond Earth, then this would be sufficient to justify more investments in space travel and colonization, which might potentially ensure the existence of humanity beyond Earth. What implications would it have if we found evidence of life on Proxima B? First and foremost, it would call into question long-held beliefs regarding the singularity of the human race. When it comes to the concept that life is not limited to the planet Earth, it is possible that religions, ideologies, and cultural narratives will need to be modified. If we were to find evidence of life beyond our solar system, it would have a profound impact on a variety of scientific disciplines, including biology, chemistry, and even medicine. It would provide fresh insights into the process of evolution and the variety of living forms, which might potentially spur the development of technologies and solutions that we have not yet conceived of. The narrative of Proxima B is never going to be finished. With each new observation, we gain a deeper understanding of this strange planet that revolves around a star in the far distance. Our knowledge of the cosmos has already been enhanced as a result of Proxima B, regardless of whether it is a barren wasteland, a place where complex species live, or a place where microbial life exists. The discoveries that were made by the James Webb Telescope serve as a reminder of the limitless curiosity and inventiveness that humans possess. They demonstrate that even in a universe that spans an endless amount of space, we are able to discover solutions to the most deep concerns. There is a possibility that Proxima B is merely the first step in our path to the stars. It is a stepping stone. What do you think awaits us on Proxima B? A second Earth, an alien world, or something entirely unexpected? The universe is vast, but one thing is certain: our quest for knowledge will never stop.